did. So first of all, I opened this textbook in the other window to show you a very important list of formulas that we already saw previously. So you go at the very, very end, you just scroll this down to the very last page of this textbook, then you should be able to see all of the formulas that we need put together. That's the good thing, and it's very convenient. So I'd like to make sure you have access to that. Let's see, it doesn't really show them formulas. Oh, it takes a little time to. So, so here we have, first of all, that unit circle, circle radius 1. Let me make it a little bigger. So in that unit circle, we utilize to actually answer various questions related to the angles. So that's very helpful, I guess. So you don't have to draw it every time. You can just look at this last page. Also, there are formulas or so-called identities, trigonometric identities, which is same as formulas that we observed previously. So it's a tangent and it's a reciprocal cotangent. And that's actually stated here. Cotangent is a reciprocal of tangent and vice versa. And also cosecant, which is a reciprocal of sine, and secant, which is reciprocal of cosine. So these are good things to know. And also, along with definition of sine and cosine that happen to be nothing else but x and y coordinates of a point on a circle with radius 1. So if you connect any point on a circle with radius 1, so I put 1 here, so we know it's radius 1, with center, with the origin, then for angle, they called it as t, I believe. We have sine and cosine, such as coordinates for that point. So y is a sine of t, y coordinate, and x coordinate of that point is cosine. So as soon as you remember this, then you will get a very good feeling about trigonometry. So yes, that's really the key, one of the key things, because if you remember that definition, everything goes just fine. Like in the previous class, if you encountered logarithms and if you have no clue what it is, then you always have issue. But if you know just definition that logarithm is a power, so you know it's power, that's it. That's power. I need to raise base to get the number. So that's a power. So what is sine? Y coordinate. What is cosine? X coordinate of the point on the unit circle. So you can always treat it as a pair, cosine t for x and then sine t for y. So this is probably the most important thing that we are learning right now, because again, if you feel comfortable with this definition, then you will always get unit circle in front of yourself and produce the answer for the exercises. I would say half problems in this class will be related to this. And that's, I guess, good to know. That's one of the main secrets. So for this whole chapter, you just need to know sine and cosine, x and y coordinate, actually y and x. And of course, there are cronies such as tangent and so forth. And we already know that whenever you need to find what tangent is, then you divide sine by cosine, right? That's another thing to know. Or look at the list of formulas that should be on it as well. So let me try to just refresh your memories, because I don't think I did exercises. I don't think I asked you to do exercises related to the quiz for that. So maybe I can try to find something that has tangent in it, like say problem number 36 I just saw, and simplify it. So I'm in section 2 of chapter 6, section 6.2. I know that people like to know the page, so advice is always look at the top of the file. It's a quick access, page 409, when we have this textbook. And now I'm going to think of what is tangent of 45 degrees equal to. And turns out the tangent of 45 degrees is same as a sine 45 divided by cosine of 45. So I need to, I guess, go to that last page, to the unit circle, and see what is sine 45 degrees and what is cosine of 45 degrees. And if you remember, they both were the same, and they both were equal to something like a square root 2/2. I memorized it because if you see it again and again and again, and if you see it more than 100 times, then it'll definitely be memorized. But I don't make you memorize anything in this class. You just want to look at this circle with radius 1. That's why they put this ones here. And 45 degrees angle, which is right here. Or you could also treat it as pi/4. Pi/4 is same as 45. So they also help you with conversions. And you can see that this will be a sine, cosine, x coordinate is cosine, and y coordinate is sine. So that's our definition. So instead of sine, I put radical 2/2, and the denominator is also the same, radical 2/2. So you divide the same thing by the same thing, so they will cancel each other. So it's just 1. So cosine 1, and tangent is 1. So this whole thing is 1. And I need just a cosine of 30 degrees, which is going to be dealing with x coordinate, right, of that. And this is radical 3/2. So I guess over weekend it'd be good if you looked at this circle and start to get used to it, because I know there are a bunch of numbers in it, and you just want to learn how to read it without a panic. Because if you panic, you just shut down and that's it. But you don't need to panic because you have plenty of time. So whatever is left, this root of 3/2 is going to be your answer. We also saw last time that we could use a calculator, the scientific calculator. So just type scientific calculator to do this exercises. So first choice in Google, Desmos, and you can just enter in it your trig expressions, but make sure that between degrees and radians, you see, you want to choose degrees because you're given now degrees. Otherwise, if you have radians, of course, it'd be a totally different result. So tangent of 45. So now I can't put the symbol degrees, but I just made this selection with word degrees. And also notice this is equal to 1, and that's what we just figured out when we were able to cancel sine, cosine. So it is helpful, of course, to use a calculator. So if you will put cosine of 30 degrees, you are not gonna get a nice answer like a radical 3/2. And that's the point why I show you that, because in these exercises, they don't wanna have this decimal approximation, even though it's absolutely correct. When I say, so what about test, Alex? Well, on the tests, I'll be in a good mood when I grade it. So when I grade it, I'm not gonna pick if you wrote radical 3/2 or gave me some kind of decimal. As long as it's correct, then it is correct. So I'm not gonna try to discipline somebody, say, oh no, you didn't give me that answer because I wanted the other answer. Well, if you do it right, that's perfectly fine. But, and I know that some people like to use their calculator, and it's good that you can use a technology, right? But in these exercises, if you decide to do it, and if you see the answer at the back of the book, by the way, all of the odd problems have answers at the back of the textbook, so you can always check your answer. So you can actually see that answer will be in this format rather than decimal, because they say do not use a calculator. And that's the way to, I guess, realize why your result may not be identical with a textbook, because they don't want you to use a calculator. So they also, in the next group of exercises, let me do one more, like 55, say find the values of 6 trig functions, which means that I need to find the value of sine, cosine. So there are actually 6 answers that I have to put for just one exercise. It's going to be kind of tedious, right? So it's sine 405, cosine 405, and the rest. But turns out the rest of them, such as tangent and its friend cotangent, so tangent 405, to produce, I just need to divide my previous two, sine by cosine. That's, again, definition of tangent. Then you need to, 405. Then you need to flip everything, which means that for cotangent, which is 1 over tangent, I just flip the last one. For secant, I flip cosine, and for the cosecant, I flip sine. Cosecant. I'm gonna flip sine. So I guess that's pretty much straightforward. And that's why I would say if you can do one of these problems, then you probably don't want to waste your time to write more, because you just keep doing the same thing basically, right? But it's worth to try over a weekend, maybe redo exactly the same exercise, because it's just a bunch of writing that takes a little time here. So I just want to write it nicely. Almost done. So now it's time to go to the end of the textbook and look at the unit circle and see what is dealing with 405. And please notice that's actually 360 full rotation plus 45. So you're actually going to deal with the 45 degrees angle. How about that? So if I move to that new favorite unit circle, that's too messy, and write this tangent, which is sine over cosine. So I just need 45 degrees angle here, because again, when you look for the 405, so that's 360 plus 45. So you end up right here. And that's something we already encountered, right? So these will be square root 2 over 2, and the other is also square root 2 over 2. And now it just goes. We already know that when I divide the same thing by the same thing, it'll be 1. If I flip 1, it's also 1. If I flip the other 2, maybe I can go back to the textbook so I get more room here. So if I flip the other 2, I actually have to flip this square root 2 over 2, so it'll be 2 over square root of 2, right? So if I take a reciprocal of this function cosine, just here, just same. But they don't like this square root in denominator, so what they can do is either factor 2 back and then cancel one of these square roots, or you could multiply and divide by square root, because at the end of the day, the answer will be the same. It'll be radical 2, and same would be here as well. So it's not hard, it's just straightforward algebra to get 6 functions if you already have sine and cosine. I guess that's the key part of this main idea. So in this section, they just want you to get used to these tangents, cotangents, because there is really nothing special in those, and that's why I guess I'm gonna move on to the next part of the story here. So I'm not gonna worry about this rest after this bar, because again, that's something that we have in a pre-calculus, and trigonometry textbooks usually don't get that deeply into the story. But if over weekend you will try to do one of these word problems and would like to have me trying, just let me know, because they're good exercises. Some of them might take you about 40 minutes to do. They're lengthy, and that's why I don't really concentrate on those, because again, that's a specific of pre-calculus textbook, and we're not taking pre-calculus class, right? We have pre-calculus is a separate class that you may take after this if you want. So anyways, today, as I said, I will be brief and just want to introduce you the next section, the story of the next section that is talking about, well, the same exact sines and cosines again. So it's really hard to say where one section ends and where the other starts, because they just keep on talking about ideas of the sines and cosines. As you can see in the pictures, they get to the bigger angles and so forth. So I just want to look at the exercises here, because I guess they don't really bring us with much of the new information. They keep telling us same exact identities again that we just saw in the previous section, that secant and cosecants are reciprocals of cosine and sine. So I don't think we see much of the new things. But here come a couple of, actually 3 interesting formulas that I would like to discuss right now, and maybe do a couple of exercises related to those formulas. Those formulas are so-called Pythagorean theorem. And the first one, I'm talking about the yellow box with number 5 next to it, is a classical Pythagorean theorem that we already saw last time, that talks about right triangle. So let me get to it through our new friend unit circle. So if I get some point on it, I already know that there'll be 2 sides in this right triangle, so 90 degrees angle. So the angle now they decided to call theta. So they changed it to theta. From now on, they will use a Greek letter theta rather than t. And I told you the reason why, because if you have cotangent, for example, of angle t, that's kind of odd word, COTT. So that's kind of confusing. That's why they always use theta for marking the angle. So anyways, if this is a unit circle and the point on it has one of its coordinate equal to cosine, the x coordinate, right, of theta, and now the other side of this triangle will be here, another column here, and it's exact same as a segment when you produce the perpendicular. So that will be called sine, right? Y coordinate. See, again, we're in the same page. We're again at the definition. So since hypotenuse is 1, and I know that if I have a right triangle, A, B sides, and C is hypotenuse, then sum of squares of sides is equal to a square of hypotenuse, right? So if my sides are here, A, and here, B, then for A, use cosine squared. So that's straightforward from definition of sine and cosine, plus sine squared, sine is instead of B, is equal to 1 squared, right? Which is 1. And this is our nothing else but Pythagorean identity. And it turns out there are 2 more formulas that called Pythagorean identity that follow, 6 and 7. But let me first use that one to do the exercise, because I don't want to throw at you so many formulas at once. This section, again, has a whole bunch of formulas. That's why today I plan to only start it. And next time I will continue with that. So let me try and let me try to find exercise that deals with this formula. So I'll be selective here for now. So let's see. How about 77? Pretty straightforward. I think the exercises that use this formula are pretty straightforward, because notice this is just Pythagorean identity. How about that? Sine squared plus cosine squared is equal to 1. So that's Pythagorean identity. Well, I say, so you miss it, skipping all this section? No, I will return back to it. I just want to, first of all, be kind of brief today. And also I want to start new ideas of these formulas that actually going to be used a lot, especially this sine squared plus cosine. You will see throughout the whole course. That's probably the most popular formula that we're going to use. Now there are 2 more here that talk about 1 plus tangent squared is equal to secant squared. So that's something totally different. Not really. If you rewrite tangent and secant using sines and cosines, and that's actually advice whenever you deal with these functions, you can always go down to sines and cosines, and then everything becomes very clear. So instead of tangent squared, I put sine squared over cosine squared. Instead of secant, I put 1 over cosine, right? So since it's squared, then it'd be cosine squared on the bottom, and 1 squared is still 1 here. So notice that if I have this identity, then I can actually clear denominator, which is a cosine squared. So I can multiply by the same expression both sides. And this means that I also have to multiply by cosine squared each piece of that fraction. And of course, it's angle theta. Cosine by itself makes no sense. It's just like if you put square root. If somebody writes, okay, square root. Square root of what? See, you want to put angle with cosine, definitely. So point of this is to cancel our cosines, so there'll be no denominators. And then look at what we got. Exact same identity, right? Because 1 times cosine squared is cosine squared plus sine squared. And this is equal to, looks like just number 1, right? I'm trying to put thetas. So we indeed have that formula. So nothing special, even though it looks quite different. Tangent, secant. So in the future, we will manipulate with tangent, secants, as well as cotangent and cosecant. So it turns out tangent and secant behave pretty much same way as a cotangent and cosecant. So sometimes the minus pops up, but the idea is that if you write that second formula here in the box on the bottom, who is again cosine over sine, and that be 1 over cosine, doing the same manipulation, you will end up with Pythagorean identity. And that's why exercise like 78 will be making little sense if you just want to subtract from secant squared tangent squared. So you bring it over to the other side, and you're going to end up with 1 is equal to secant squared minus tangent squared. So it turns out that this is just the manipulation with a formula. So if they say secant squared minus tangent squared, of course, angle has to be the same, no matter what it is, 18 degrees or 40 degrees or whatever else, the result is 1 because it works for any angle whatsoever. So I think at this stage, it could be a good idea to stop and to, well, if you feel like you can do some more, try to do some more problems in this group only. So we kind of starting at the end, because to get to the previous, I need to introduce you with a little bit more information, which will be done next Tuesday. And today, I promise to let you go a little earlier to start enjoying the Labor Day, the long weekend. So no quiz today, just have a good time, or some people might use it to catch up because some people still owe me quizzes, and I am waiting. I have patience, but I want to make sure that you actually do it, okay? Whoever didn't do it. If you're already done with quizzes, then you know that you did it, so you don't need to worry. But I'm saying it to those people that still working on it, right?